And our final example, noticing again that this is getting similar to what we did with gravitational fields. Okay, here we have two negatively charged spheres and they're arranged as shown in the diagram below. We have to determine the electric field strength at a point halfway in between. First, we figure out the electric field caused by each charge individually at the point halfway in between. Okay, so I want to know what the field is like right here, halfway in between. So the first thing I did is I took that distance and I divided it by 2. Then the electric field from 1 is kqr squared. So I'm going to put for my charge as this guy right here, 1.2. I multiply that out, I divide by the radius squared or the distance squared, and I get a value of 1.28 times 10 to the negative 11. So make sure you're pausing and you're trying these calculations, okay? And that you can get the same answer I do. Now, remember this is, well, what would a positive charge do here? So if I had a positive here, since this guy's negative, it would be attracted or pulled towards the negative. So I say this is towards the left, towards charge on the left. Okay? Now I have to see, well, what does this red ball do to this point right here? I put in the values, my k is a constant, 3.9 is the charge here, and then I put the distance in. When I get that, I get 4.16. Well, if I had a positive charge sitting right here, it's going to get pulled towards the negative. So this is getting towards the right. So I have one electric field pulling it to the left and one pulling it to the right. Okay? So what I'm going to have to do is I'm going to have to take this value and I'm going to have to subtract my 1.28. Okay, by subtracting that 1.28, because this is going to the right and this is to the left, I subtract those two values. When it was all done, I got this 2.8 times 10 to the negative 11, and then I put it in sig figs to be 2.89 times 10 to the 11 newtons per coulomb to the right. So again, just vector addition there. So make sure you're pausing, you're getting the same values, you're understanding the directions as well. There are going to be a number of homework questions for you to try now. The answers are given. Make sure you understand how to do those calculations and their units and their direction.